We continue on with factoring today. What does greatest common factor mean? I'm going to abbreviate that GCF because it's too long to write out. What does that mean? Any ideas?
The factor is like the biggest factor that you multiply divided into each.
It's the biggest factor that each term has, correct. The biggest factor in each term. So, for example, if I were to ask you to factor 12x cubed plus 18x squared. Whenever you see the word factor, the first thing you should always look for is a common factor. Always, always, always. Because if you factor that out, it's going to make all your numbers smaller and all your power smaller. It's going to make life easier for you. So you start with the numbers, 12 and 18. What's the biggest factor that 12 and 18 have in common? What's the biggest thing that can divide 12 and divide 18? 6. So I put a 6 there. And then you look at the x's. You've got an x cubed and an x squared. What do they have common? X squared is always the smaller of the two exponents. So you put an x squared here. And then you put a parenthesis. 6x squared times what will give me the 12x cubed back? 2x. So I have a 2x. And then I need a plus, because that's a plus right there. And then 6x squared times what to get the 18? 3. Just a 3 on that one. We don't need the x, because 3 times 6x squared gives us 18x squared. We already had 18x squared, so that matches. We don't need an x on that one. Questions on that one? All right, how about factor, I don't know, somebody give me a good number. 21? 21 x squared y to the 5th minus 28 x to the 4th y cubed. Is it a big deal that I put more than one letter in there? It really shouldn't be. You look at your numbers. What's the biggest thing that can divide 21 and divide 28? 7. You look at your x's. What do your x's have in common? 2. You always look at the smaller one. This one's an x squared. That one's an x to the 4th. The smaller one is the x squared. How about your y's? Y cubed. That one has 5. That one has 3. Y cubed. What's left over? 3y squared minus 4x squared. You said plus. It should be minus, right? Because that's a minus in the middle. Watch your signs on that one. Yeah, that looks right. Because 7 times 3 gives me the 21. I already had the x squared, the x squared. Y cubed times y squared is y to the 5th. That one looks right. 7 times 4 is 28. X squared and x squared is x to the 4th. And then we've got the y cubed. Perfect. Questions on that one? All right, how about factor 3x squared minus 15x minus 18. What would you do on that one? Well, not divide by 3, but you're close. 3 is the greatest common factor. So you can't just divide by 3 because it's not an equation. If I had equals 0 over here, then we could divide both sides by 3. But it's not an equation. It's just an expression. But there is a common factor of 3. So we take the 3 out. What's left over? X squared minus 5x minus 6. Now the question is, can you do better? Can you factor x squared minus 5x minus 6? Yeah, so you got to look for that. Sometimes you take out a GCF. After you take out the GCF, you can factor more. So we're going to have the 3. The 3 is just going to stay there. We factor the x squared minus 5x minus 6. x minus 2, x minus 3? I don't think that's right. Why not?
No, it's 1, so.
Yeah, what's wrong with that? Negative 2 and negative 3 does give the negative 5. But unfortunately, negative 2 times negative 3 gives a positive 6. So you got to be careful. You got to make sure you get them both right. That's a very easy mistake to make right there. That's not the right answer, unfortunately. 3, I heard somebody tell me I need an x minus 6 and an x plus 1. Negative 6 and 1 does give negative 5. Negative 6 times 1 does give negative 6. That's the right answer. Okay, so watch out for that. Make sure you get both numbers to work out correctly. Let's see, how about, I don't know if I can steal a good one out of the book here. Negative 4, x to the 4th y, plus 12x cubed y squared, plus 40x squared y cubed. What would you do first? Find your GCF. Okay. Who's your GCF? There's a 4 in common to all the numbers. I agree with that. How about the letters?
4x squared y.
4x squared y. Okay, that's pretty good. But I think we're going to do better. Because think of what's going to happen here. If I do 4x squared y, when I draw my parenthesis, what am I going to get right in front here? A negative 1x squared. I don't like to factor when that first thing is negative. It's much more difficult to factor when that first thing is negative. I want it to be positive. Right. So that's a common thing that we do. If this first term is negative, typically we make our GCF negative. So for this GCF, 4x squared y, it will work. But you're making life harder for yourself. If you make it negative 4x squared y, things are going to be a little bit better. How does that affect things? Well, it makes the first one just x squared. What's the next one? Negative 3xy. Yeah, now you got to be careful of your minus signs. We need a negative 3 because negative 3 times the negative 4 gives me the positive 12. So if you're going to put a negative out front here, it's going to change all the signs inside the parentheses. So watch out for that. So that's negative 3xy. And then the last one is negative 10y squared. Again, change the sign there. Negative 10 times negative 4 to get the positive 40. Okay, so that can be very helpful. Sometimes it's very helpful to make your GCF a negative number. And I think this is a good example of that. Because now I think it's pretty easy to factor the rest of this. Final answer looks like negative 4x squared y. And then what? Well, x and x to get the x squared. How about on the ends? Minus 5y and plus 2y. Why do I need the y's? To get the y squared. So y times y will give me y squared. So minus 5y times 2y gives me the negative 10y squared. And the negative 5 and the positive 2 add up to be negative 3. Questions on that one? All right, now we're going to do something called factor by grouping. And we'll see why we want to do that here in a minute. Factor by grouping is a technique that you use when your polynomial has 4 terms. So what I mean by that is I might have x cubed plus 3x squared plus 6x plus 9. So this has 4 terms. 1, 2, 3, 4. The first thing I would do is I would look for a GCF. Is there a GCF? 3? Not 3. 3 is common here, here, and here, but there's no 3 in the first one, is there? So it's got to be a 3 everywhere. So I don't think 3 is a GCF. Yeah, I think 1 is the only GCF, so that doesn't really help us. All right, well, this is called factor by grouping because when we have 4 terms, what we're going to do is we're going to group them in pairs. So I'm going to group the first 2 and I'm going to group the last 2. And I'm going to take the first 2 and I'm going to take out the GCF. What's the GCF for the first 2?
1.
Not 1.
X squared.
X squared. 1 is the GCF on the numbers, but they do both have x's in them, don't they? So I can take out an x squared. And I'm left with
1 plus 3.
x plus 3?
1.
It has to be x because x squared times x gives me x cubed. Yeah, that's an x cubed there. Plus, you know what? The teacher screwed up. I think. This isn't going to work. All right. Well, that's fine. It won't work on. That's good to talk about too. This is what happens when you make up problems off the top of your head. Sometimes you make mistakes. What's the GCF for the next piece? 3. And left over is 2x plus 3. Now, what is supposed to happen? The parentheses are supposed to be exactly the same. So that parenthesis should be exactly the same as that parenthesis. In this case, the teacher made up a problem off the top of his head, and he made a mistake doing so, and those parentheses are not exactly the same. When those parentheses are not exactly the same, what does it tell you about the polynomial? It's prime. That's correct. So that can happen. It wasn't intended to happen, but this can happen. This polynomial is prime. It does not factor. All right, so let me try again. Let me fix the problem. How about 2x cubed plus 3x squared plus 6x plus 9? I didn't change it much. I just slipped a little 2 into there. Once again, I notice I have 4 terms. I look for a GCF. The only GCF is the number 1. That's the only thing that divides all of them. Doesn't do me any good. No GCF. Okay. No GCF, that's fine. I go to my grouping. I group the first 2. I group the second 2. What's common in the first 2? X squared. And left over? 2x plus 3. Plus, what's common in the next group? 3 still. And left over? 2x plus 3. Okay, now we're in good shape. Now, this parenthesis perfectly matches with that parenthesis. And when I say perfectly, I mean perfectly. If this one was 2x plus 3 and that one was 2x minus 3, they don't match perfectly. Everything has to match exactly. Why do we want those to match exactly? That's now the common thing. What's the common thing on each side of that plus sign? Well, on the left-hand side, I have a 2x plus 3. On the right-hand side, I have a 2x plus 3. That's now the common thing. So I'm going to take out the 2x plus 3. And if I take out that 2x plus 3 from here and here, what's left over? X squared plus 3. Questions on that?
So you won't have to put parentheses 2x plus 3 squared. You won't have to.
No, because if this were say, let's say this was x squared times 5 plus 3 times 5, you would just take out a 5, wouldn't you? Not a 5 squared. And you would write x squared plus 3 because you have the 5 times the x squared and the 5 times the 3. So This is common. You're just taking this, bringing it out front. So now think of doing FOIL. You would take 2x plus 3 and multiply it by x squared. That gives you this one. And then you would take 2x plus 3, multiply it by 3. That gives you that one. So not a squared there. There's only one of them that comes out. Other questions on that one? All right. I'm going to steal some out of the book here so the answers come out right. 5a squared x plus 2a squared y minus 5bx minus 2by. All right, so again, the thought process I go through, first off, I look and I count 1, 2, 3, 4 terms. That tells me I probably want to use factor by grouping. But before I do factor by grouping, I always look for GCF. Is there a GCF?
No.
Unfortunately, 1 is the only GCF. Not going to do me any good. So, no GCF, that helps. 4 terms, I group. Put them in pairs. What's common in the first group?
A squared.
A squared. So that's a squared left over.
5x
5x
plus 2y.
plus 2y. I might have copied that down wrong originally. I might have put a y squared there. I did. Yeah. No, I put my 2 in the wrong spot. I think I said the right thing. That should have been 5a squared x and 2a squared y. I put my little 2 in the wrong spot there. Okay, how about the second group? What's common in the second group? A b. However, once again, notice that the first one has a minus in front of it. When the first one has a minus in front of it, what do we want to do? Take it out. So not only is our common factor b, our common factor is also going to have a negative. So you want to take out a minus b there. When you take out a minus b, what's left over? 5x plus 2y. Very good. Remember, when you take the minus sign out, it changes all the signs inside. And a good check is, if I'd written 5x plus 2y here, and I'd forgotten to change that sign, and I wrote 5x minus 2y there, that's a good hint that I probably made a mistake, because these parentheses really should match up. If they don't match up, you've made a mistake, most likely. All right. Well, I'm in good shape now. What's my GCF? 5x plus 2y. That's common to both sides. And left over?
A squared minus b.
A squared minus b. Questions on that? All right, so this factor by grouping, this is the technique that we use to factor trinomials where a is not the number 1. What does that mean? That means something like this. Factor 6x squared minus 13x plus 6. Here's the problem with this one. We know that our answer really should look like this. However, how do you get 6x squared to come out in the front? It could be 3x and 2x, or it could be 6x and 1x. Which one's the right one? There's no way to know. And what you have to do is you have to guess. Okay? And then, how do you get a 6 on the other end? Well, again, it could be 3 and 2, or it could be 6 and 1. Which one's the right one? You don't know. So what you would have to do is you'd have to make some guesses. I'm just going to make a guess here. Do Do I want to use 6x and 1x or 3x and 2x? 3 and 2? 3x and 2x. And then I'm going to guess 3 and 2. And then I try to see if I can make the numbers work out. Well, 3x times 2x is going to give me the 6x squared, so that's good. On the outside, I'm going to have a 6x, and on the inside, I'm also going to have a 6x. Is there any way I can put together a 6x and a 6x and end up with a negative 13x?
No.
No. So what does that tell me?
Can be 3 and 2.
One of my guesses is bad. Or, even worse, maybe my guess is correct, but I should have put the 2 there and I should have put the 3 there. Because now it makes a difference when I do FOIL, doesn't it? Because now I have a 9x and a 4x. I get different numbers. So you can see the issue is when this number is not the number 1, you could be guessing for a long time before you happen to hit upon the right combination. Or, even worse, maybe this polynomial is prime, and you have to guess and you have to try every single one of them and show none of them work, and then your answer would be prime. A lot of work to say, I can't do it. All right, so we use this grouping technique. The guessing technique here isn't very good. This grouping technique is much better. And here's how this grouping technique works. We notice we have 3 pieces. We notice there's no GCF. We start by multiplying the numbers on the end. So we take 6 times 6. What's 6 times 6? 36. We then need to factor the number 36 to try to make it work out so that the 2 numbers add to be negative 13. So what are the different ways you can factor 36? Negative 9 and negative 4. Negative 9 times negative 4 gives positive 36. And negative 9 minus 4 does give negative 13. So that's the right way you want to go. That's the right way to factor 36. We're going to come back here, and we're going to rewrite this. We're going to rewrite this as 6x squared. I'm not going to write minus 13x. I'm going to split it. I'm going to write it as minus 9x minus 4x, and then I still have the plus 6 on the end. So notice what we did. We took this 13 in the middle, and we split it into those 2 pieces that we got over there. Now, how many pieces do we have?
4.
We have 4 pieces. What do we do when we have 4 pieces? Now we can factor by grouping. All right, so I group them in pairs. What's common in the first pair? 6, not 6. 3x. 3x is common in the first pair. Left over? 2x minus 3. And how about common in the second pair? Negative 2. Excellent. Once again, you notice that this first number was a negative. When this first number is a negative, we want to take out a negative. So we're going to take out negative 2. And left over, 2x minus 3. Very good. When you're doing this factor by grouping, when you started with 3 pieces, those 2 things always have to be the same. If they are not the same, you definitely made a mistake. Okay, so I take out the common thing. The common thing is the 2x minus 3. When I take out that 2x minus 3 from each one, 3x minus 2 is left over. Questions on that? All right, so the moral of the story is when you go to factor and this first number is not the number 1, it's harder to do. No way around it. Yes?
Can you explain the 6 times 6 times 36?
Right, the way this technique works is you always multiply the numbers on the end. Always, always, always. So 6 times 6 is 36. And then you've got to work it out to get the number in the middle. All right, let's grab another one here, and hopefully that'll help. How about 3a squared minus 2a minus 6. I begin by looking for a GCF. Do I see a GCF? No, unfortunately. I notice I have three pieces. 1, 2, 3. I notice this first number is not the number 1. So when I have three pieces and this first piece is not the number 1, I multiply the ends. So I'm going to take 3 times negative 6. What's 3 times negative 6? Negative 18. So you always start by multiplying the two numbers on the end, keeping the signs. 3 times negative 6. I now need to factor the number negative 18 to make it come out so that they add to be a number negative 2. How can you factor the number negative 18? I could use 1 and 18, 2 and 9, 3 and 6. I think those are the only possibilities, aren't there? Is there any combinations of those numbers that I can fiddle with to get a negative 2? No, I don't think so. So what does that tell me? It's prime. So when the answer comes out to be prime, it's nice. It happens real quickly, and you're done. Again, if I were doing this by the guessing method, I'd have to put a 3 and a 1. I'd have to try all the different ways to get a 6, try to work them all out, all the different signs. I would be guessing for quite a long time before I determined that I wasted all my time. It didn't factor anyway. That would make me angry. All right, so let's try another one here. See if I can find one that isn't prime. 16x cubed. Minus 32x squared plus 12x. 16x cubed minus 32x squared plus 12x. What would you do? Excellent. And that's something that it's very easy to forget to do. You get in the habit of saying 1, 2, 3 pieces, multiply the ends. Remember, that's not your first step. Your first step is GCF. What's your greatest common factor? 4x. Left over. 4x squared minus 8x plus 3. All right, now here's what I like to do. If I can factor out a GCF, I kind of like to just write down 4x, because that's going to stay. And then when I get all done, I know my answer is going to look like that. But I like to go off to the side and deal with this piece that's left over. Because it gets confusing with this 4x on the outside. Where do I write it each time? Where do I go? So I like to just write it down, the 4x, the 2 parentheses. I know that's going to be my final answer. Deal with this off to the side. Figure out how to factor it, and then I'll just plug it in when I get done. Okay, now I notice I have 1, 2, 3 pieces. I notice there is no GCF. This first number is not the number 1. That tells me multiply the ends. 4 times 3 is 12. Can I factor the number 12 to make the pieces add up to be a negative 8? Can I get the number in the middle? Yes. How? I wrote them as negative 2 and negative 6. Does the order that I write them down matter? Would it matter if I write negative 2 and negative 6 or negative 6 and negative 2? No. So you told me negative 6, negative 2. For no particular reason, I changed the order. Just because I felt like it. All right. So we come back here. We write 4x squared minus 2x minus 6x plus 3. We change the negative 8 into a negative 2 minus 6. We group. Common in the first group? 2x. Left over? 2 2x minus 1. Excellent. Where'd that minus 1 come from? Yeah, I've got to have 2x times something to get a negative 2x. A lot of people will just write, they won't put the minus 1 there, they'll just leave it blank. And then all you have is 2x times 2x, which gives you 4x squared. You lost the negative 2x part. That's a very common mistake to make, very easy to do. You've got to have a minus 1 there. Minus. What's common in the second group? 3. Left over? 2x minus 1. Excellent. So, our common thing, our brackets match up perfectly. We like that. That's 2x minus 1. Take those away. 2x minus 3 is left over. So, we got to go back now. Our final answer for this problem, we've got the 4x. Then we have a 2x minus 1 and a 2x minus 3. There's the final answer for that problem. Questions on that? Questions on anything?